Hey, what's up guys, welcome back to this video. In this video we're going to solve this coding interview question, Pascal's triangle 2. This is a LeetCode coding question. Given an integer row index, return row indexed row of Pascal's triangle. So it zero-based index. If we don't know what is a Pascal's triangles is a triangle where the value on the left edges and the right edges 1, and for first row and for second row we have the value 1 and 1 and 1. Then we have to generate the value, and we have to generate the value by adding the value on the top. So here 2, 1 plus 1 is 2, here 3, 1 plus 2 is 3, then 2 and 1, here 3. So here 1 and 3 is 4, so 3 and 3 is 6, 3 plus 1 is 4. For example, if you're given row index equals to 0, then you have to return the first list of index 0. That means this list. If you're given row index equals to 1, then you have to return this list of index 1. If you're given row index equals to 2, then you have to return this list at index 2. If you're given row index equals to 3, then you have to return this list at index 3. If you are given row index equals to 4, then you have to return this list at index 4. If you're given row index equals to 5, then you have to return a list at index row index from our Pascal triangles. If you are given row index, then you have to return a row from Pascal's triangles at index row index. It's zero-based index. Now, how we can solve this problem? The brute force solution to this problem is that first we'll generate the Pascal's triangles from index 0 to the given row index, in this case from index 0 to 6, and we'll return the list from index 6 from our Pascal's triangles. And this is going to be brute force solution. If you want to solve this problem using this naive approach, then you can watch the video Pascal triangle. We have the video in this section. That is the previous video of this video. Now, can we improve this solution? Yes, we can improve. Let's see how we can solve this problem in efficient way. So at index 0, what we will do, we'll insert 1. Okay? So at index 0, we have the element 1 here. First, what we will do, we'll create a list, and in that list, we'll insert 1. And this is for our index 0. Then for index 1, what we will do, we'll append a value here. We cannot use here array data structure. We have to use resizable data structure. In Java, we can use a list. That means array list. We'll iterate from 0 to the row index. Okay, for this given input 6, we'll iterate from 0 to 6. So we have appended here 1. Now, in each step, we have to keep track our previous row. And this is our previous row, right? We clearly see that this is our previous row of this row 1 and 1. And here we have to do nothing. And inside here we will run another loop from index I-1 to, from index I-1 to 1. From index I-1 to 1. And this is the value for I. And this is the value for j. So here you have j I-1 to 1. Here you have 0 to 6. And we'll iterate here from right to left, not from left to right, from right to left. We'll iterate from right to left, not from left to right. So using this inner loop, we will iterate from right to left. Now here, what we're going to do, we're going to do nothing here because this inner loop will not execute for I equals to 1. Then you have to generate the value for index 2 from this value. Okay, so for that here, we will just insert 1 at the end. So let's add here 1. Now we have to keep track the value in our previous row. And we see that this is the value in our previous row. So here we can generate the value by adding the top value on the top of this element here. Okay, so here we have to generate the value. On the top of this element, we see here we have the element 1 and 1. And this 2 element is the element on the previous row. Here we see these 2 elements is the element we get from our previous row. Okay, we'll keep tracking our previous row in this array. So we can keep track our previous values. If we add this 2 value and if we update the sum of these 2 value here, then we get here 2. So let's update this middle with 2. Now for next row, so for 3, what we'll do first, we'll append here 1. So let's append here 1. So here we added 1 and we see that this row is at index 2 here, okay? So this row at index 2 and we have to generate this row. We know the previous row right here. So what we will do, we'll iterate from this element to this element. First we'll update this element, then this element. So on the top of this element 1, here on the top of this element 3, so we have to generate this element 3. We have 2 and 1. So here we see we have the element 1. Here we should have 3, and we can get that by adding this 2, this current and the previous element. If we add the previous and current, then we can update this element with value 3. Now let's go to the left here. What we will do, we will add the top 2 elements, that means this element and the left, and we'll update this 2 with 3. Now we're iterating from right to left, not from left to right. Now let's answer to this question. So here we have 2 and 1. If we iterate from left, then we'll have 1 plus 2 is 3. And here we'll have 3 plus 1 is 4. So we're losing our value. That's why we're iterating from right to left. Okay. Now we generated the value for index 3. Now let's generate the value for index 4. Let's generate for index 4. Now what I will do, we'll append 1 in this list. Let's add here 1. Now we'll iterate from this element to this element. And here we see that this is the previous row. This is the row at index 3. So we can generate these 3 elements using this value here because this is the previous element. So if we add 3 and 1, we get 4. Let's update this value with 4. Then if we add this 3 and 3, then we can update this value with 6. Then if we add here 3 and 1, we can update this value with 4. So this is the row at index 4, right? So here we see that this is the row at index 4. Now let's generate the row at index 5. So let's generate the row for index 5. Here what we will do, we'll add 1. Let's add 1 in this list. Now we see that previous row, okay? Okay, 1, 4, 6 for 1. Now we'll iterate from this element to this element. Let's update this value. We'll add this and on the left. So here we'll get 5. Let's add here 5. Now let's update this value here. So 4 and 6 we'll add here. 4 plus 6, that is 10. Then here 6 and 4, let's update this value with 6 plus 4, that is 10. Then here 4 plus 1 is 5, so let's update this value with 5. So we generated the row at index 5. Now let's generate the row at index 6. Here we have to generate the row at index 6. First we'll append here 1, and here we see that this is our previous row, and we have to update the value from this index to this index, okay, from I-1 to 1. Now what we will do here, first we'll add this current and on the left, so we'll add here 6. Now here for this 5 plus 10 is 15, so let's update this value with 15. Then here we have 10 and 10, that is 20, so let's update this value with 20. Right here let's update this value with 20. Then here we have 10 and 5, so let's update this value with 15. Right here, then here let's update this value with 6. So 1 plus 5 is 6 here, so we update this value with 6. So we get this list. This is the row at index 6. So if we're given the row index 6, we have to return this list. This is the row at index 6. And we're not using extra space here. So here we have to use a resizable data structure. We cannot use a fixed data structure like array. We have to use here array list. Array list is resizable data structure for Java programming language. This is how we can solve this problem. Hope you have understood how to solve this problem. The solution will take big O of n squared time complexity, where n is the given index, and the solution will take big O of n space complexity. So here we're reducing the space complexity from quadratic to linear. For the problems Pascal triangle, we're solving this problem in O of n squared space complexity, because in that case we have to construct the entire Pascal's triangle to solve this problem. But here, instead generating a Pascal's triangle, we're solving this problem logically. Hope you have understood how to solve this problem. Now let's see the pseudocode. This is the pseudocode to solve this problem. We have this function getRow. It takes row index as input, then we're creating a list, the row, Then we're running a loop for I from 0 to row index. Then we're adding 1 for each iteration. Then we're generating our current row with the value of previous row, because on the left we have the previous row. We'll run this loop from I minus 1 to 1. The condition is that I need to be greater than 1. Then we're applying this formula and we're returning the row at the end. If we're given row index equals to 3, let's see how we can solve this problem. For row index equals to 3, at index 0, we'll insert one element in this row. So let's insert here 1. The inner loop will not execute. Then for index 1, we'll append here 1. Let's append 1 here. And the inner loop will not execute because I is not greater than 1. Now I is 1. Then for next iteration of this outer loop, we have here index 2. Let's append here 1. And here we see that we have the previous row. With this previous row, we can calculate the element at index 1. This is the previous row, so we can generate this row. Here we have 1, so we'll add this 1 and 1, so we get here 2. Then for next index, that means for index 3, we'll add here 1. Let's add here 1. And this is our previous row, okay? Using this previous row, we can calculate the value for this and for this. So let's do that. So on the top of 1, we have 2 and 1. With this previous row, we know that. Okay, so if we add here 1 to 1, just for sake of understanding, this is our previous row. On the top, we have 2 and 1. So if we add this 2 and 1, so we get here 3. Let's erase this last part. Just we're doing it for sake of understanding. Then on the top of 2, we have 1 and 2. So if we add this 2, we get here 3. So we're done. We get this row at index 3 and we'll return this row. And this is how we can solve this problem. Hope you have understood how to solve this problem efficiently. If you want to solve this problem using the naive approach, first you have to generate entire Pascal's triangles from index 0 to row index. Then you have to return the row at index row index. Hope you have understood this solution. This solution takes big of n squared time complexity, where n is the row index, and it will take big of n space complexity. Hope this concept was clear. If you have any question, if you have any suggestion, let us know. Thanks for watching this video. I will see you in the next video.